Let's go through Activity 1, cleaning the UT alumni dataset. So the first thing that I'm going to do is to make sure that R is looking in the right folder for reading in data files. So we saved this file from an Excel spreadsheet, and we're going to use read.csv to read it in. But we saved it to a specific location, and we need to make sure that R is looking in that location in order to read it in correctly. So what I'm going to do is I'm going to go into Session and then Set Working Directory, and choose the directory to be where that file is located. Now for me, I have a BAS47x folder. In my Assignments and Activity 1 folder, I see that I have the alumni CSV file. So what I'm going to do is I'm going to click Open, and I can see that the path is currently going into that folder that I know the data file is in. And I'm going to go ahead and uncomment that line and then run this line so that we read in that data file. We'll see it appear in the environment. You can get a little preview of what some of the columns are like this. And now we're ready to work with it. So question number 1 just asks some basic information about this data set, namely how many rows and how many columns does this data frame have? Well, that information is available to us if we look in the global environment. We see almost 44,000 rows and 84 different columns, but there are some commands in R that will actually tell us what these values are without us having to do any sort of counting here. So one thing we can do is ask for the dimensions with the command dim of our data frame here, and if we were to run this, that'll print out the number of rows and the number of columns right here. If we just wanted the number of rows, well, the command is nrow, and the number of columns just by itself is ncol here. So I could run either of these and those reproduce those two numbers, the same ones that we see up here. Alright, so now we're asked to use head to print out the first few rows of the screen and run summary to take a look at what we're up against here in terms of data cleaning. So if I type in head, the name of the data frame, and then the number of rows that I want to see, I think by default it's 6, what it will do is it will print out to the screen the first 6 rows, or however many you requested, of the data frame. We see this is a pretty big data frame, a lot of different columns here, so a lot of different outputs. So scanning through a little bit, what we see is that there's some issues like missing graduation dates here, missing campuses. Going a little bit farther down, we see some weird symbols going on, and we see that there are dollar amounts with actual dollar symbols in it, and commas. We'll have to deal with that. We see dates, which are notoriously hard to work with. And we actually see some columns that don't look like they contain any sort of information. So there's a few data issues we're going to have to worry about. We can run summary on this as well to get either the 5-number summaries for the quantitative variables or a frequency table for the levels of categorical variables. So if we were to scan through some of these things, what do we look for? Well, gender code, here's the frequency table of this. It looks like we have a few unknown genders here. For city, that tells us that, all right, the majority or the most common level here is Knoxville, but there's a lot of different cities in this data frame here, about 29,000 different individuals who live in other than these top 6 cities right here. We see area codes being treated as a number, so it's giving the average, which doesn't really mean anything. But anyway, we do have definitely some work cut out for us. Some cases where we have really rare levels, like the campus someone got their degree from, only one person from UT Medical Center, one person from UTN, whatever that's supposed to be. So we see some issues. So we see missing values, dollar signs, weird symbols, rare levels, etc. Alright, so question number 2 asks us to get started with the data cleaning process, and first to tackle these last few columns of the data frame, X, X1, X2, X3, X4. Looking at the summary, we see that actually every single value is NA, so for some reason I think when we save the Excel spreadsheet into the CSV file, it appended 5 blank columns here. So how do we get rid of a column? Well, we null it out. What does that mean? Well, we specify the name of the column here, along with the data frame. Alumni $X refers to the X column of the alumni data frame. And we just left arrow it and tell it to be null. What that will do is it'll delete that column in its entirety from the data frame. Look what happens when we run this line up in here. Currently we have 84 different variables in the alumni data frame. Once I run this, we'll see that it gets down to 83. and that column is now lost to the ages. So we can just copy and paste this. We know we need to get rid of the column x.1, x.2, x.3, and x.4. So I can highlight those 4 lines, send it down to the console to get rid of those. We see the number of variables in our data sets decreasing. And we also want to get rid of the ID number column here. Now, since we're just going to be doing some sort of descriptive or maybe predictive analytics, we know that the ID number is just some identifier variable. It doesn't contain any information about, say, how much the alumni is going to donate, whether or not they're a major donor. It doesn't have any information for us. It's just useful for identifying what row belongs to what alumni. So we can go ahead and, for this purpose, just null that out as well. And you'll see that it completely disappears from the list there. And so we've gotten rid of a bunch of columns that we really don't need. All right, question number 3 asks us to deal with monetary amounts. Now, unfortunately, when we saved this data set from Excel, it preserved the format that Excel was presenting the money formats in. So it's going to be putting in the dollar signs. It'll put in commas. Now, we could have just gone to those columns in Excel and saved them as numbers instead of currency. But hey, let's imagine we're stuck with this and let's learn how to actually deal with this. So number 3 introduces a really useful command called gsub, which is good for manipulating text around. Whenever you have entries in vectors or entries in columns that are text, how do you replace one letter with another? Basically what we want to be doing is we want to be taking the dollar amounts and just taking out the dollar sign, taking out the comma, and just making sure R is treating it as a number. So this first R chunk right here just describes how gsub works. So let's go ahead and define a vector called x. It's going to be a character vector because its entries are just words here. And let's imagine, for whatever reason, we want to go through each element of x and replace all of the lowercase e's with capital E's. All right, how do we use gsub to do this? Well, the way gsub works is the first argument, in quotes, is going to be the character that we essentially want to be replacing. We want to be getting rid of the little e's. The second argument, in quotes here, is going to be what we want to replace it with. So replace the little e's with the big E's. And the third argument tells us where to look to do that replacement. So basically look inside the elements of the vector x and do that for each element here. So notice when I run this line, we'll see that indeed every instance of a lowercase e is now a capital E. And we can get a little bit fancier here. What if we wanted to replace all double L's in each entry of x with the numbers 7, 8, 9? Well, gsub works similarly. It's going to look for all instances of 2 L's back to back, and it's going to replace that with a 7, 8, 9, and it's going to do that for each element of x here. So running this command, we see that this double L in hello becomes a 789. Notice that the single L in let stays a single L because it was looking for double L specifically, and so it's done that substitution. All right, well, what if we wanted to replace more than one thing with something else? Well, here's how we would do it. We're going to invoke some square brackets here to give it a list of characters that we want to replace. So this last command right here, in double quotes and then inside square brackets, we give a list of characters that we want to have replaced. Now in this case, the second argument, what we're replacing it with, is just a pair of double quotes with nothing in the middle. That basically says, all right, let's replace all the vowels that we see in each element of x with just an empty space here. Not even an actual space, like pressing the space bar, but just nothing whatsoever. So we see that running this line here, we see that all the vowels have been taken out of the entries of x, and there aren't any spaces in between the letters once that replacement's been done. So we need to do something very similar to our currency vector. We basically want to take the dollar signs and the commas and replace them with nothing whatsoever. All right, now there's something a little extra that we have to know about when we replace dollar signs, and that is R treats the dollar sign as a very special symbol. It's what we use to refer to a particular element of a data frame. It's what we use when we refer to a particular element of a list. So we can't just go and refer to a dollar sign as the character dollar sign without a little bit of a modification. So how do we handle this? Well, if we want to refer to the actual text of a dollar sign, we need to actually reference that as 2 backslashes followed by the dollar sign. R will treat these 3 characters together as just a single dollar sign. So for example, if I define my vector x here, which is a currency vector with dollar signs and commas here, if I were to run this g sub command, what it's going to do is it's going to, since we have square brackets here, it's going to look inside the square brackets. It's going to say, all right, I'm going to replace the dollar signs and I'm going to replace the comma, each character inside the square brackets, and I'm going to replace it with nothing because I have a pair of double quotes with nothing in the middle, and I'm going to do that for each element of x. And so what we see is that indeed that's what's happened. All the dollar signs have been stripped out and the commas have been stripped out as well. All right, so we're almost there. Basically what we need to do is for each one of these columns in the alumni data frame, strip out those dollar signs, strip out those commas, and then make sure that R is treating them as numeric values. You'll notice after running this gsub command, we're still actually left with a character vector. We see quotes around the entries, and so R is treating that as words instead of numbers. So we'll have to use the asNumeric function to basically tell R, hey, treat these as numbers, not as anything else. So let's do this for the first column here, the lifetime gift to the Haslam College of Business. What we want to do is basically just steal this code from up here, because it's already told us how to replace dollar signs and commas with nothing, and just update basically what we're doing that to. Not the vector x anymore, but instead the entries in this particular column of the alumni data frame. So how do I refer to that column? Well, I type out the name of the data frame, then the dollar sign, and the name of the column. So if I do this, what this command will do is it'll go through each entry of LTG to HCB, and it'll replace any instance of a dollar sign or a comma, and it'll replace it with nothing whatsoever. Now if I just run this command, what that'll do is it'll print it to the screen because I don't have a left arrow, I'm not saving it to anything. Let's run and see what happens. And you'll notice that it successfully does that. You don't see any commas, you don't see any dollar signs anywhere. However, you do notice that every entry is still a character because we see double quotes. So we actually need to say, hey, treat this as a numeric quantity. So basically we want to take the output of this command and put that inside the function as.numeric. As.numeric will take an R object and it will try to force it into numerical form if possible. So if I were to run this, it's still going to print out to the screen because I'm not saving it. There's no left arrow here. And we see that now we're dealing with a numeric vector. There aren't any quotes, so these are actual numbers. And essentially what we want to do is we want to put this back into the LTG to HCB column. So I can use the left-hand arrow symbol to do that. Basically, I want to say alumni dollar sign LTG to HCB. Left arrow, basically take the result of this command and put that in to that column. So what we'll see is right now it's treating it as basically a factor, a categorical variable here. And what we'll do is run the command, scroll down once again, and what we'll see is that the definition has been updated here. It is now a numeric object here, and here are some of the numbers that we see. All right, so now we're asked to do that for all these other columns, and there's really a quick and easy, efficient way to do this, but it involves some advanced R coding. So let's just make it easy and as straightforward as possible, and just kind of reuse this code, copy and paste here, and just go ahead and copy and paste the names of the columns that we need to go and apply this procedure to. So nothing very glamorous. We can see that it's a bit tedious, and looking ahead, we're actually going to learn a way to do this automatically, and that's going to be using what's called a for loop. It's basically going to say, all right, you want to do the exact same thing over and over and over again, but maybe change one thing every time you redo it. Like in this case, we're changing the column name that we're applying this procedure to. Well, you can do that with a for loop. So stay tuned. Next week or the week after that, we'll be talking about how to write these sort of commands that'll make our life a bit easier. But for now, with just a little bit of copying and pasting, we're able to basically come up with a nice procedure that takes away all those dollar signs, all those commas, and now all of the values inside these columns here are going to be treated as numbers. The numbers that they actually are here. So we're very happy about this. Looks like we're successful. All right, so moving on to number 4 is another issue that we're going to have to deal with. Degree 1 grad date. A very weird column. The way they're storing the graduation date is bizarre. So we can see right now that the type of object that this column is an integer object. It's all integers in this field here. Some are NA. But what we see is that the very first 4 digits of the graduation date looks to correspond to the year, and the last 4 digits say something about the month of graduation, like spring, winter, summer, fall. So what we're going to do is a bit of data processing. We're going to extract the year and extract the month out, but we need to be a little clever about this. We need to figure out basically how do we get those first 4 digits and how do we get just the last 4 digits. And so I have some hints here in the very first chunk of our code here. Let's imagine that we're dealing with this particular graduation date. Let's define a vector x, which is just going to be a number, which is basically the year 1970 and graduating in August, say the summer of that year here. So what if I just wanted the year? Well, here's a trick. What would happen if I divided this number by 10,000? Well, what would happen is I would get 1970.08. Now, all I need to do basically is to lop off the decimal portion of that number. And that's exactly what the floor function does. The floor function says, all right, I'm going to look at all the digits that come before the decimal place, and anything after that decimal place, I'm just going to throw away, basically rounding down to the nearest integer. So if I were to run this, we see that 1970.08 becomes a 1970, and so we see that, oh, well, that's a great function to get the graduation year out. All right, well, what about those last 4 digits? Well, we have to be even a little bit more clever. I'm not going to really walk through why this equation works, but you'll notice that if I were to run this command here, this command basically extracts those last 4 digits. We ignore that preceding 0 before the 8. And so you'll just have to take my word for it. This expression, this operation right here, is able to extract those last 4 digits. All right, so let's actually create some columns for the graduation year and the graduation month. Part A asks us to add in the column called graduation year. So let's go ahead and do that. How do we add a column to the data frame? Well, we say the name of the data frame, $, and then the name of the column that we want to be adding. So we want degree 1 grad year. And we need to say, well, what goes inside this column? We need to left arrow it and basically say, all right, here are the values that I want it to be. So what are the values that I want it to be? Well, the way that we get the graduation year out of there is basically to take the value inside the graduation date, divide it by 10,000, and then take the floor. So instead of x here, I'm basically taking the values inside the graduation date column. So alumni $, degree 1 graduation date to extract that column. Notice if I just run this portion of it, we see, here are all the years. There's some weird values like a 0 and NA. That's kind of bizarre, but that's extracting the year as we have it. So now we've added in an additional column. That's the graduation year. And now we want to add another column to represent the graduation month. But we need to do a little bit more processing with this because instead of representing it as a number, we're going to want to convert that actually into a factor with 4 levels. 5 levels in this case because sometimes we don't know what the graduation month is. So let's go ahead and define the graduation month column. Something very similar to what we did before to add a new column. Name of the data frame, $, then the name that we want that new column to have. I'll make liberal use of copy paste here. And what do we want it to be? Well, this operation up here was able to extract what that month was. Now, where are we taking the month from? Not from the vector x here, but instead we're taking it from the degree 1 grad date column of the alumni data frame. So we just replace x with the values inside that column. Notice if I just run this right here, I see that these are all the year parts of those graduation dates. So let's go ahead and define the column grad month, add that to the data frame, and now what we're going to do is we're going to treat it as a categorical variable. What you'll notice right now, if you ask for the class of object that this column is, it's a numeric quantity here. And really we want to be treating graduation month as a categorical variable, like winter, spring, summer, etc. So the first step is to basically convince R to treat it as a factor instead of a numerical variable. Now how can we do that? Well, we can use the factor command. Basically what we're going to do is we're going to take the values inside degree 1 grad month and make it a factor just with the factor command here. And we're going to put that in, we're going to overwrite the values that are in the grad month column right now, so that when I run this, you'll notice now if I ask for the class of this column, it is now a factor. So, all right, let's learn a little bit about this factor now. How often does each level appear? And what levels do I see? What possible values do I see? And I see something a bit peculiar here. So zeros probably represent an unknown month of graduation. 300 is probably winter, 600 is spring, 800 is summer, 1200 is fall, just based on the relative frequencies. But then we have to wonder, well, what are these other bizarre entries here? What's 602? What's 608? We don't really know, and so in this case, what we want to do is actually recode those extraneous bizarre levels as just unknown. Pretty much the same thing as a 0 here. So what we want to do is we want to recode these levels. A lot of ways to do this. Let's do this the least inefficient way, or least efficient way, but probably the most straightforward. So how do we modify what each level is called? Well, what we do is we use the levels command. So levels, alumni $degree 1 grad month, gives us a vector of the different values that we see in the degree 1 grad month column here. So these are all the level names. And we can modify that with the left arrow symbol here. Basically, if we give it a vector of new names, then it'll replace the old name with the new name on an element by element basis. So how does this work? Well, let's make a vector with the C command here. What do we want 0 to read? Well, we want that to be unknown. So I take the very first level in the levels output here, the 0, I'm going to call that unknown. All right, the 300, I say I want to be called winter. So I'm going to put winter in double quotes. 318, 511, 512, well, those are all unknown values here as well. So what I'm going to do is I'm going to use the rep, a nice little command to basically repeat something a certain number of times. And I'm going to repeat unknown a total of 3 times to correspond to 318, 511, and 512. 600, I say up here, I want to be spring. 602, 605, this, and this. I have 1, 2, 3, 4, 5, 6 unknowns all in a row. So I want all those 6 to be called unknown as well. Press a comma. I'm going to press return to go on to the next line because this command is so long. Then we have 800, which I say to refer to as summer. Then we have 822, which is unknown. We have a 1200, which we're going to denote to be fall. And then we have 1, 2, 3, 4, 5, 6 levels that we want to replace with unknown as well. So we're going to modify what these levels are called directly by saying levels of our column of interest is now equal to this vector of new values here. And they just match up. The first thing specified in this vector is the first level. The second thing specified is the second level, etc. So I'm going to run this command, and I'm going to look to see what the levels are again. And we see that now we only have 5 levels: unknown, winter, spring, and fall. And what we're going to do is we're going to look at a summary just to confirm that we did this correctly. So I say be on the lookout for these numbers for each one of the levels. Confirm that there's 3121 unknowns. Yep. 3003 winter. Yep. It looks like we were able to get that command right here. All right. So now that we've extracted the year and the month of graduation, we don't really need the degree 1 grad date column anymore. So let's go ahead and null that out as well. We can get rid of it by referring to that column, left arrow null. That's going to get rid of it, and we no longer have to worry about that. All right, question 5 asked us to deal with the city column, which is the city that either the alumni was living in before coming to UT, or maybe it's where they're living now. Without the data dictionary, we're not exactly sure. But one of the issues with the city column is that it's ambiguous because it's only the city name, and very often the same city name appears in lots of different states. Springfield appears in 41 different states. Franklin appears in 24 states. So if we really want to utilize an alumni's location, what we really should do is combine city and state together to make a kind of unique set of values. So this chunk right here illustrates a very useful command called paste, which basically takes two elements and just smushes them together. So what do I mean by that? Well, let's go ahead and define two vectors, x and y. So x might be the three different city names, Springfield, Franklin, and Clinton. Y, say, three different states. And what I want to do is basically create a vector that says Springfield, Illinois, Franklin, Tennessee, Clinton, Tennessee. Well, paste does exactly that. Paste x comma y is going to look at the vectors x and y, and it's going to make as the first element of the output basically the first element of x and the first element of y combined together. Now, by default, it's going to leave a space in between these two elements, and so that's why we see the result being Springfield, Illinois with a space, Franklin, Tennessee with a space, etc. We don't want that space, or if we want something else to separate those elements, we can specify what we want to be separating them with the sep equals argument. A pair of double quotes with nothing in the middle basically says, all right, don't put anything between those two elements, like what we see here. So let's go ahead and merge the state and city together to create a column called location. So how do we create the column called location? Well, alumni $, our new column name, and we're going to left arrow it and we're going to say what we want it to be equal to. Well, basically what we want to do is we want to take the entries in the alumni data set, the city column, and we want to paste them together with the entries in the state code column. Now, it's a matter of choice what we want separating those two values. I personally don't like any separation, and so I'm going to say sep equals double quote with nothing in there. All right, so if I do this, that'll create a new column called location, but let's be a little careful here, because if I look at what type of objects R is treating the values, we see that it's actually treating it as a character, basically just a sequence of words. Now, since we want to do maybe some sort of analysis, maybe compare the average donation amounts for each city that we have in the data set, we need to actually make sure that R is treating it as a factor instead, the list of values as well as a list of levels, the possible values that we can have. If we want to do any sort of model building, we need it in the terms of factors as well. So what we're going to do here is update the definition of what the location vector is. We're basically going to say, all right, let's now have the location column be the values inside that location column, but being treated as a factor. And so now, if I look at the class, the type of object, we see it's a factor. So it's keeping track of the list of values, as well as all the levels. Basically the set of unique values that it sees. All right, so now that we've created this location column here, maybe we need to do some data processing on it. So I say, all right, let's just take a gander at the first few levels of the location column that we made. We could look at all the different levels just by with that levels command. We see there's a little over 4,200 different cities represented in this data frame. It turns out the ones at the very beginning of this list are actually the problem ones. So if we look at the first 6 different levels, the first 6 different unique values of this categorical variable, we see that we have a blank that's actually just a true blank. We have a blank which looks like there might be 2 spaces. We have a blank TT, and these 3 are just invalid city names here. Basically, it just means it was unknown, or whoever was recording it put in some sort of some nonsensical value here. So what we're seeing is we need to do a little bit of modification on the levels here. All right, so there are some bogus entries. We basically want to take those first 3 levels of this column, this blank, the 2 spaces, and the space TT, and let's recode that to be unknown. So what we're going to do is we're going to do this with the levels command once again. Levels alumni $ location is a vector, and we can left arrow it and basically say what we want each value to be. Now, I'm not going to go through and specify, all right, keep everything the same except for those first 3, so I'm not going to have a line with 4,200 different entries, I'm just going to be clever and say, well, really, the only ones I need to modify are the first 3 elements of that levels vector. Well, I can get those first 3 elements by putting square brackets and then the vector 1, 2, 3 here. If I run just this part, I see that, okay, these 3 values here, and then I can just specify what I want those values to be. Now, since I all want them to be the same thing, I actually can just say, set it equal to unknown. So once I run this, well, I can once again look at the first 6 entries. You'll notice that I don't have any blanks, no spaces, the space dt, but I do have a level called unknown. So how many locations are unknown? Well, we could make a frequency table and look it up, but there's 4,200 different cities. That's going to require a lot of scrolling. Why don't we use the which command? So if I say which alumni $location equals unknown in quotes, what this will do is it'll go through this vector here, basically the location column of the alumni data frame, and it'll check to see, all right, is that entry equal to unknown or is it not? So this will return a bunch of trues and falses. If I run it, let's go ahead and run it here. And it converts that into basically the locations where I do see that statement being true. So it's basically saying, all right, the 43,975th element of this column here is unknown. So if I just count up the number of elements that I have in the result of this which vector, that's going to tell me the number of unknowns. So length and which play together nicely because it basically counts up the number of times you see a particular value. Length which alumni $location equals unknown tells me the number of unknowns. Looks like 673 locations are unknown for the alumni here. All right, number 6, and actually the first number 6 because there's a second number 6 here, talks about the city.1 column. Now, it turns out this tells us the city in which the alumni is currently employed, if known, but it's not known for a lot of employees here. So this column has a very low information density because most of the cities actually in the column here are just represented once. Like Omaha's in there once, Orlando's in there once, and most of the time it's just a blank. So basically what we want to do is greatly compress the values inside this column here to just be basically missing versus present. Do we know where they're living or do we not know? All right, so part A asks us to find out how a missing value is represented in this column. Well, levels will print out all the unique values inside a given vector. So let's take out the city.1 column of the alumni data frame. If we run this, we see that we see about 110 unique cities here. And scrolling up to the top of the list, it looks like unknown is just a blank. So not a space, not a tab, it's just there's nothing in them, there's nothing in there at all. And so we can use this information to basically recode the levels to be something a little bit more useful here. So since most of these cities appear only once, let's go ahead and actually just group all of these cities together into a single level called known, and all the cities that we don't know about, all the blanks, to be unknown. All right, so we're going to recode the levels once again with the levels command here. How am I going to do this? Well, if I say levels alumni $city.1 with the square bracket 1, notice that's going to be the first element of this vector of the levels. If I just print that out, it's basically that blank right now. That is what I want to convert to unknown. Okay, I'll run it. Let's look at the levels now. We see scrolling back up, it's no longer blank, it's referred to as unknown. All right, now what I want to do is I want to make Alpharetta to be known, Andover to be known, Atlanta to be known. Basically everything else I want to change from what it currently is to just the word known. All right, well here's some nice way to exercise some shortcuts about referring to elements in R. If I do levels alumni $city1, that's the vector of all the levels of that categorical variable. If I turn on the square brackets to refer to particular elements, remember you can refer to all but a particular element by putting a minus sign and then the number that you basically want to ignore. So levels alumni $city square bracket -1 means all but the first element. So if I were to run this, I can see that this is indeed all but that first element. The first element was that word unknown. This is a list of basically all the elements that I want to be changing, and that's great. So I can just say, recode those to be known. All right, so let's see what the results are. How many cities do we know about? How many cities don't we know about? Let's just make a table of the values inside this column now. And we see that we know 656 cities. The vast majority of the time, we don't know what city the alumni is currently employed in. All right, so city.1, ambiguous, not a good column name. Let's go ahead and rename that to be something else. Let's call it city_employed. All right, so how do we do that? Well, we're going to use the names command, and we're going to modify the names of the alumni data frame directly. Now, if I just run names alumni, that's going to be a vector of all the different column names. And similar to the levels command, I can actually change what those names are with the left-hand arrow symbol. In this case, the only value that I want to change is this city.1 name here. And if I kind of count down through this vector of names, I see that that is the 8th element. So I could say name square bracket 8. Left arrow, I'm going to make it something else. I'm going to call it city_employed. So that's kind of the quick, kind of low budget way of actually doing this. A better way, what if I wanted to change the name of SPD4 campus? That's deep inside this vector. Who really wants to count exactly what element position that is in? Well, I could use actually the which command to help me out. What if I did something like this? If I did names alumni, and then in square brackets said, all right, well, which of names alumni here is equal to city.1. Remember, the way that which works is it looks through all the elements of this vector here, and it finds all of those positions that meet the logical condition that we specified. In this case, are they equal to city1, or are they not equal to it? So if I run this little command right here, it prints out an 8 because, indeed, going through element by element, it's only the 8th position whose value equals city.1. So I'm actually going to delete this command. That's kind of the low budget way, and this is the classy way of doing it. This way, if I were to change the ordering of the columns, it wouldn't necessarily be the 8th column anymore. This is a much better way to go about running this command. So I'm going to, oops. All right, so yes, that's the name I want to change. What I want to change it to, I want to change it to city_employed. So I've got it. I can look at the environment window, and we can see now there's no longer city.1 column. Instead, we have city_employed. All right, last question. It's really number 7 here, is dealing with this lifetime gift to UT, something that we made a numerical value by stripping out the $, stripping out the comma earlier on here. Now, as is typical with many quantities in business analytics, the original values have an extremely skewed distribution. What do I mean by that? Well, let's look at a histogram of the values inside this column with just the default histogram. This is a completely worthless visualization. Every single value for the lifetime gift to UT basically lives inside this one bar, and there might be maybe 1 or 2 outliers, someone who's donated tens of millions of dollars to UT. Now, the whole purpose of a histogram is to look at the shape of the distribution, and we have no idea what it looks like because the information's been compressed, and it all lives inside this column here. So we say that this distribution is skewed because it has a long right-handed tail. Basically, it has a smattering of very, very big values, which makes the distribution hard to visualize. Now, the most common trick that we use in business analytics to handle this is the log trick. Instead of analyzing the original values, instead, let's analyze the logarithm of those values, specifically the log base 10 of those values. So let's go ahead and look at a summary of the values in the lifetime gift to UT. We see that the maximum value, some person donating almost $50 million to UT here, but there's a lot of people who've never donated at all. The median is still 0, so we know that at least 50% of the alumni here haven't donated ever in their lifetime. So if we want to use the logarithmic trick to make this distribution more manageable, we actually need to be a little bit careful because we can't take the log of a negative number and we can't take the log of 0. That's an undefined operation. So how do we get around that? Well, here's a nice little simple trick. Let's actually add 1 to each value for the lifetime gift to UT and then take the logarithm. So is that okay to do? Well, I think so in this case because we see such a vast range of values inside the lifetime gift that adding 1 really isn't going to change our impression of donation habits. That will change the average value from 58.15 to 58.16. Very, very tiny change. So let's go ahead and do this, and let's actually create a new column. Let's create that column called log LTG to UT. And what we're going to have that be is the log 10. We're always going to want to work with log 10s here in business analytics. They're much more easily interpretable. We want to take the log 10 of the values inside the lifetime gift to UT after adding 1 to it. So once we run this command, let's actually look to see at a histogram of values just to see how effective this new presentation is going to be, how much more easy it is to interpret what this distribution looks like. Well, let's run it, and here's our histogram. A lot more resolution, a lot more detail, a lot more interesting things to talk about. First of all, since now these are the logarithmic values instead of the original values, the numbers on the axis need to be interpreted in the right way. With us doing log base 10s, when we see a 2, that actually corresponds to a value of 100. When I see a 4, that corresponds to a value of 10,000. It's basically the number of zeros that follow the 1. So it looks like we see a peak at around a little over $100 here. This bar right here, it represents probably all those people who never really donated. We took zeros, we added 1 to it. The log of 1 is 0 as well, so we have this big bar of these alumni that have never donated. Here are the ones that have, and it looks like of the ones that have, well, the more common amounts are in the few hundred. It's pretty rare for someone to donate more than about 10,000. Really rare for someone to donate more than 1 million here. All right, so for the participation credit this week, you were asked to find the average of this new column. How do we figure out the average? Well, a few ways to go about doing that. We could actually get it directly by asking for the mean of this column, 1.099. Or, of course, if we just run summary on this column, we get the average and then a whole bunch more. So if we get the summary of this, we find that the average is 1.099. This shows us the maximum value as well. On the logarithmic scale, basically 10 raised to the 7.7 power. And there we go. Looks good. Can we knit this file? Well, let's see. Let's try knitting it to an HTML. That'll go through and it'll run each line of code one by one to make sure that we've done it right. And the fact that it's compiled says that, yes, we're definitely good to go. So there you go, activity 1.